Generators. In this video, we will be covering AC and DC generators. Generators are used to turn mechanical energy into electrical energy. Electrical generators in power plants supply most of the world's energy, with the remaining being photovoltaic, such as solar panels, or even chemical, which is batteries. So just briefly how most power plants work, whether they be nuclear or coal, they take a fuel source and burn it. This heat turns water to steam. Steam is passed through into a turbine, which rotates an axle, and this is the bit that we're going to be concerned about, is that rotational energy, how that's converted to electricity. There are two types of generators, ones that produce direct current, or DC, and ones that produce an alternating current, or AC. So looking at the parts of a generator, in both cases that we're going to be looking at, a coil, denoted in both these diagrams, rotates in a magnetic field. The rotational energy is provided by a mechanical power source, with the ends of the coil connected to a circuit. Due to the coil being rotated, brushes are used as part of the circuit to ensure that the contact is made with the coil at all times. Let's focus on the motion of the coil in the magnetic field first. In this situation, the coil is rotating anti-clockwise, and if we use our right hand palm rule, our palm on this right hand side of the coil will face up, our fingers will point to the right, and our thumb will be pointing towards us, which suggests that the current will be traveling down out of the page in this coil. As this is a closed circuit, that means that this other side here, the current will be traveling up. When the coil makes a half a rotation, the current will be actually traveling in an opposite direction. So when this part of the coil, where this side is now, it will be traveling in the opposite direction. So naturally, this will produce an alternating current. So going further into the operation of a generator, as the loop rotates, the magnetic flux through the area of the coil is constantly changing due to its movement in the magnetic field. This changing magnetic field, or the magnetic flux, induces an electromotive force in the coil, which causes a current to flow within it. The slip rings in an AC generator or commutator in a DC generator and the metal brushes provide constant contact between the rotating coil and the connections to the external circuit. Looking in detail at a DC generator, the current that's produced is a direct current, and you can see in this diagram here, the current is always in one direction. In this case, it's always positive. A DC generator has commutator and brushes. The commutator is very similar to the slip ring, however it's got brakes in it. In an AC generator, the current is periodically being changed, as you can see in this small diagram here. So it goes from positive to negative to positive to negative. So the DC circuit had one commutator. The AC circuit has two slip rings. Looking at the animation at the top here, this is an AC generator. So you can see that each side of the coil is permanently attached to one slip ring. So what that means is that one end of the coil is producing that alternating current. So first it's positive, as it goes through the half rotation it goes negative and periodically changes. So what that means is that one end of the coil, as it's attached to the slip ring, goes both positive and negative. The other end of the coil is the opposite. So in this configuration, and you can see on the little green dial here, the output is positive, then negative, then positive, and then negative. It's an alternating current. In the lower animation, we've got a DC generator. When the commutator is in the upper position, the current is coming out of the page. It doesn't matter if it's the red or the blue side of the coil. So when the coil goes through its rotation, when it's at the top, it's always coming out of the page. And having the circuit set up in this situation allows us to have the direct current. I'd like you just to spend a couple of minutes having a look at this link on the page, which I'll provide in this video as well. Have a look at both the DC and the AC generators and the force lines that are presented in this diagram. So comparing the two in this diagram, everything above this red line in the diagram is the same in both cases. It's a rotating coil in a magnetic field. As the coil moves through the field, the current that is induced in the coil will move the same. It is when it's connected to the circuit in a different manner that the output is different. state two differences between AC and DC generators.